Alrighty, so we're focusing on the problem 11a on your review sheet, which is f of x equals 2 sine 3x plus 4. So you immediately see some changes happening to your parent function. So I've written down most of the variables from our parent function so we can see exactly what's happening. So we see that there's a 2 in the place of the amplitude, a 3 in the place of the omega, and a 4 in the place of our k, or what determines our midline shift. So first we're going to see exactly how those changes are going to impact our graph. So first of all, we know that 2 is in the space of our amplitude. So we know that our amplitude, or the height from the center line to the top of our graph, our peak, is going to be 2. It's no longer 1, but now it's stretched up to 2. Then we can look at our omega. What difference does our omega make? Remember, omega affects period, but isn't period. You have to plug in the number you have in omega into the equation, 2 pi over omega, to figure out what your whole period is, or what one full cycle, what one full turn is going to equal. And so in that case, we see that it's 3. So our period is 2 pi over 3. I'm going to skip this interval step real quick. Remember that 4 is in the place of our midline shift. And there's a difference between adding outside of the equation and multiplying. So amplitude and period is when you multiply numbers. But when you're adding, that is a shift. So remember that a 4 affects your midline, or where that center is. And so we know that we can draw a line at y equals 4 on our graph, because that is where the center line is. Now, back to period, the fun one. So to find your intervals in a period, remember that you always divide period by 4. And we're left with 5 points when we get that. We'll talk about what that means in a second. But for what we're going to do first is grab the period that we got from plugging into the equation, plugging omega into the equation, and we're going to divide it by 4. So when you do that, remember, when you divide by a fraction, you multiply by its reciprocal. So 2 pi over 3 times 1/4, which simplifies to 2 pi over 12, which further simplifies to pi over 6. So that is our interval. We know that if we were to make a table, which we will, our graph is going to increase, or our intervals are going to increase by pi over 6 each time. And so then we have an XY table. I'm going to draw one right over this one. And we know that our first point is 0. So what happens if our interval is pi over 6? That means that we have to add pi over 6 every time until we get 5 points that we can graph. So first we start with 0. Then we got to add pi over 6 to 0 to get our next point. That is just going to be pi over 6. Now we need 3 more points. So let's start with pi over 6, because that's where we were first. We're going to add another pi over 6, because our interval will always increase evenly. That will give us 2 pi over 6, which you can simplify to pi over 3. Next, you're going to start with the point that we just had. I'm going to start from 2 pi over 6, which is the same thing as pi over 3. It's just easier to add because it has the same denominator, the common denominator that we've been talking about. So we've got 2 pi over 6 plus another pi over 6 for our next interval, which will give us 3 pi over 6. And this number, this fraction, will simplify to pi over 2. Now we need 1 more point. We've got 1, 2, 3, 4 points. So I'm going to start right here from this 3 pi over 6 again, because we like common denominators. We get 3 pi over 6 plus another pi over 6, 4 pi over 6, which simplifies to 2 pi over 3. So I know that's a lot of numbers, but if you need to pause and remember why these simplify, take that second. So then we're left with a table that looks like this. So now this table will help us actually graph. We know that we've got a graph right here. This is where we're going to graph our sine function. We know the midline is at 4, our center line is at 4, and we know that our intervals go from pi over 6 to pi over 3 to pi over 2 to 2 pi over 3. That is one full period. Remember, 2 pi over 3 is that full turn. So we know that this is where one full cycle happens. Now, how do we get those y values? How do we know where to graph along the y-axis to get that wave that we're so used to? So that is when we refer back to our unit circle and we start doing some algebra. We start plugging into our table to graph. So first, remember our unit circle. Remember that the magic thing about our unit circle is that it has a radius of 1. So in any direction, the edge of this circle is 1. And that's how we can figure out our coordinates. So at 3 o'clock, our coordinates will be 1, 0. Up here at pi over 2, our coordinates will be 0, 1. At pi, our coordinates will be negative 1, 0. And at 3 pi over 2, our coordinates will be 0, negative 1, right? And then you always know that cosine is your x value and sine is your y value when you are doing unit circle. You know that cosine is the horizontal height and sine is the vertical height, vertical length. Alrighty, so now with this background, we can now do the math. So we know that f of x, the equation that we've been using, is 2 sine 3x plus 4. That is an x. So we already have x values that we got from our interval. So let's plug in that first one. Let's plug in 0. So we've got 2 sine 3 times 0 plus 4. Don't need a parentheses right there. To simplify, then we have 2 sine of 0 plus 4. Now this is the step where you substitute what sine of 0 is into the equation. And you either know by memory at this point that sine of 0 is 0, or you can refer back to the unit circle you made and see that at 0, right, at 0, our y value, our sine, is 0. So you can plug that in. So 2 times 0 plus 4. This will give us 0 plus 4. So our y value is just 4. So at 0, let's look at our graph. And up here at our table actually. At 0, we know our y is 4 thanks to that midline shift. And so this is exactly where it starts, at 0 and 4. Let's do one more point. So here, we've got the same equation. The only thing that changes is our x. So now we're starting with our next interval step. So 2 sine 3 times pi over 6 plus 4. And I got pi over 6 because that is our next point on the chart we made with our intervals. So at pi over 6, now we can simplify 2 sine 3 pi over 6 plus 4. In other words, 2 sine pi over 2 plus 4. Once you simplify inside the parentheses, just like PEMDAS, the next thing you want to do is simplify what the parentheses itself. So this is where we substitute. Just like on this step, we got to 0, that this is where we substituted what sine of 0 is. I'm gonna underline that for you, what sine of 0 is. This is where we substitute what sine of pi over 2 is. And so at pi over 2, right up here, we see that our y value, our y coordinate is 1. So we can replace that. 2 times 1 plus 4 gives you 2 plus 4, which equals 6. So first you're going to put it into your table so you've got it all organized, and then you can graph. So then you see at pi over 6 in this beautiful graph that you're making with me, your y value is going to be 6. Then you can start drawing those connections as you go. And so then you need 5 points. So you're going to do that 3 more times.